now that we have found the direction of the force on a ball moving around in a circle, let me now try and calculate this force. Now, to calculate this force, I must first find the acceleration. And let's see how we can do that. So first of all, again, like the force, the acceleration has direction and magnitude. And direction is the same as the change in velocity, which we already know to be this direction, perpendicular to the velocity. So the next thing we need to find about the acceleration is the magnitude. So I must go to this triangle, and I must first find the change in velocity, the magnitude of this change, and I must then divide that by the time to get the acceleration. So from this, let me try and find the change, the magnitude of this change. Okay, clear this off. Now, to find this, I can use this triangle to help me. Now, first of all, I know the magnitude of v. That's 3 meters per second. So that gives me the length of this side of this triangle. So that's 3 meters per second. So that's 3 meters per second as well. And I know the I don't know the angle yet, but let me try and find this angle. I can actually find this angle. You see, if you look at this part here, this angle is made from this radius, this radial line of 2 meters, and the little arc here. When the ball moves for 0.001 of a second. Okay, so I'll just draw it out here to make it clearer. Now I have this 2 meter from there, and the ball moves for a short time, say over a distance s to this new position, and my angle here is the theta that I want to find. So this small distance is equal to time times the velocity. Okay, so that's 3 times 0.001 of a second, and that's 0.003 meters. So that's my little length here, and this is my radius r. So from this little picture, so this is just this part here, I can actually find the angle. I have the formula. Let's see, the formula relating the two is theta is equal to the arc length s over the radius r. Now s is 0.003, and the radius is 2. So this gives 0.0015 meter. Actually radian. So now I have my angle, and I know this angle now. So let me look at this triangle again. I have this angle. I know that this is isosceles. The two sides are equal, and I know the length on this side. So in principle, I can solve this triangle using trigonometry, maybe sine and cosine, to find this length. But there is a simpler way to do that instead of going into trigonometry, and that is that if I look at this picture here, if you look at this picture here and you compare it with this picture here, see that when the angle is very small, this arc length here is almost straight, right? It's only very slightly curved. So this is an actual arc and is nearly straight. Now if we now look at this straight line here, this change in velocity, this is a straight line. But if you imagine also drawing an arc here with this point as the center, that arc would be very nearly the same as the straight line, because the arc is so small. Okay, it's only a very slight curve. So what this means is that instead of calculating the length of this straight line, if I calculate the length of the arc, I would get very nearly the same answer, and it would be more accurate the smaller this angle is. So this makes it a lot easier, because I know that I have this formula relating the angle to the arc, to the S. So this distance here, I call it W. I'll write it this way, W. So this distance is related to this radius and this angle by V times theta. So that comes from this formula. Let me quote the formula here. The formula is the arc length S is equal to R theta, all right, which is that one. So I'm just substituting the W into S and V into R. So I have this relation, right? This gives me a very accurate value of, although approximate, all right, it's actually very accurate for very small angles. Okay, so with this, I can now calculate the magnitude of W, and that would be I know V is 3, and I know angle is 0.0015, so 0.0015, and that gives me 0.0063 times 15 is 45 meter per second, because that's change in velocity. Okay, so we have an expression for the change in velocity, and I can now, if I want to find the acceleration, I can now substitute it into this formula and divide by the time, which I also know that's the time, and I can find the acceleration, and then I can multiply by the mass and find the force. So the mass, if I don't actually have the mass, but let me give it a value. Let's say this mass is 0.2 kilogram. Okay, so now I have all the information I need to find an answer.